Okay. It's my pleasure to introduce James Cole, the Senior Director and General Manager of Security Architecture and Engineering at Intel. He has over 22 years of experience as a Senior Technical and Business Leader at Intel. And he and his team currently drive security strategy, define the security solutions spanning the Intel product lines and business units, as well as provide software for highly secure security functionalities for various Intel products. He also has his BS from Purdue. And it's my pleasure to introduce him and to let him speak today on IoT and IoT security. So,
Thank you.
yeah.
Thank you. Good afternoon. How is everybody today? Good, good. Well, thanks for having me here. I've been telling the folks I've been meeting with throughout the day, I love this place. You know, I got my computer science degree here back in 1997, and it really formed a foundation for a pretty cool and amazing journey I've been able to do both professionally and personally, and a lot of it has to do with the things I learned here both in and outside of the classroom. So thanks for having me back. Thanks for taking a little bit of your time this afternoon to spend with me. The reason I chose the Internet of Things topic is, number one, I heard that's pretty interesting for you guys, so I wanted to be sure it was something that you guys would enjoy listening to. But for me, the thing I really like about the Internet of Things is it's a very exciting market. And it's a very exciting market in terms of its potential, but the other thing, it's got a lot of complex problems that come along with it. There are technical problems, there are business problems, there are supply chain problems, there's even policy and ethics problems as you really start digging into the breadth of what IoT could be. So anywhere there's hard problems to solve and big opportunities for volume and dollars, that's a place I like to be because you really get to push yourself and do some new and amazing things. So today I'm going to talk to you a little bit about a couple of the business and technical and supply chain problems that Intel has tackled in the Internet of Things along with some of our industry partners. And I'll talk about how we're working with the industry to do that as well. And the fundamental thing we're trying to do is really take a complex environment that exists around IoT, and we'll talk about what some of those complexities are, and turn it into a plug-and-play environment where you can take any device and put it on any cloud. You don't have security issues and flaws that come along with passwords, and the activation and onboarding process really becomes automated, efficient, and very, very highly secure. Okay, so it's all, even though we're technical here, you guys haven't gone to business school yet. We're going to talk about the IoT market in general to kind of set the stage. So when I say the IoT market, you guys tell me, what are some of the things that you know about the IoT market or you've heard in terms of what are the characteristics of the market? How big is it? When's it going to take off? Anybody have any, read any articles, heard anything about these markets?
Only just the complications and
Complications? Yeah.
security flaws.
Yeah, lots of security flaws, right? Here's what I roughly can tell you about the market. So first off, it's over 1 billion devices in volume. I've seen everything from 500,000 in 2019 to 1 billion. I saw something the other day that said 1.6 trillion devices by the time you hit 2029. In the early 2020s, you're talking 500 billion in revenue, right? And again, I've seen this number go up into the trillions, right? So the point being here, I don't know how big it's going to be. I don't know how much volume is going to come along with it. But what I do know is one thing. It's big, right? Regardless of how you define it, regardless of what you put in or out of these assumptions to make this forecast work, the volume and the market opportunity are significant, right? The other thing I know for a fact, given it's what I do professionally and I've done the research on it, is this market hasn't produced at the fastest rate that was predicted. Like if you look at the IoT forecast from 10 years ago, we were probably already in some of these billions of numbers, and we're not there yet as a market. Two of the major things that are going on that makes this market be a little slower is the security and the integration are highly, highly complex problems, okay? Very highly complex problems. Some other things about the IoT market, I call it the any-to-any problem. When you're delivering to customers, and whether your customers are consumers or industrial companies, they want anything to work with anything. I call it the any device to any application to any cloud. Now, that's easy to say, stand up here and say as a customer, well, I want my stuff to work with anything, anytime, anywhere. As you guys know, as technical problem solvers, that's not always the easiest thing to do to deliver on what your customers are looking for. So these ecosystems are highly segmented. Even if you're looking at something really specific like industrial for lights or smart HVACs for a building, they're highly complex in terms of they're built with 50 million different kinds of hardware, 10 different operating systems, right? This isn't a PC ecosystem where you have basic configurations that everybody uses in one or two operating systems, right? The fragmentation is significant, right? Their complex deployment models. Are you using a private cloud, a public cloud? Is it on-premise, is it off-premise? What's your network connection look like? Is it consistent over time? These are all things that make this market like highly complex to deliver to, which again, I think is holding back some of the market and the trends. So let's first look at the onboarding and the installation problem, okay? First off, let's say a question I have for you is how long does it take to manually onboard 10,000 gateways, devices, or sensors? So gateways, devices, or sensors, think of things like a smart HVAC for a smart building, sensors on an oil rig, or even like sensors on an autonomous car. So if you were to install 10,000 of these today, and remember 10,000 compared to the numbers that are projected for this market is basically rounds to zero, right, in terms of the scale of this market. Any idea how long it would take to do something like this? Kaiser Associates Research, we commissioned them to do this survey a while back. It's over 2 man-years. Each one of these installations would take about 20 minutes up to an hour, and there are 11 different discrete configuration options you would have to do to make one of these devices, gateways, or sensors work, right? So the complexity of doing that billions and billions of times means it doesn't happen, right? The other thing to note here is it brings in some interesting policy issues inside of a factory or inside of a company, because your information technology and your operational group are now at odds. Your operational team wants to put the water fountain in and move on to install the next water fountain. Your IT group wants to be sure that whatever you're putting on your floor or in your network or in your system is done right, and more importantly, done securely, right? So you have a significant conflict going on in the market just to get these systems installed. The other complexities here, if you look at the onboarding challenge, a wide variety of systems here. I mentioned to you before, this isn't a PC ecosystem where the hardware architectures have been established for years. You have a couple of main programs that people run, a couple of operating systems, and you're done. There are literally hundreds of operating systems and hundreds of hardware configurations, right? Most of these devices are headless. You have to really know what you're doing to interface with them or bring in an external tool. Different connectivity. Some of them are wired, some are wireless, some are wired sometimes, some are wireless sometimes, and guess what? Some of them go offline sometimes, right? It's manual installation, adds a lot of cost, and it requires a trusted and skilled staff. You can't just send anyone out that's been working with regular HVACs for 30 years and have them install a smart HVAC that has to interact with a smart building, right? So the complexities here, they're technical, they're policy. As I mentioned before, there's a lot of things you have to solve to make this onboarding process work. The other topic that I want to hit on here today, something I'm passionate about, is what I think is probably one of the biggest security holes we have in the world. And that's not just for onboarding IoT devices, but it's for the phones and the tablets and the online banking that you're doing today, and that's passwords. Who here besides me hates passwords? I have to change them every 6 months. I've run out of common things, so I have to filter through all my children's birthdays 5 times with their initials. I have to do all kinds of things, and then the one on my laptop is different for one on my home system, which is different for my Wells Fargo banking application. It drives me insane. And people get lazy when passwords are involved. Anybody here familiar with the Verizon data breach report? Verizon actually publishes every year like major data breaches that happen and kind of give you the story, kind of the Harvard Business Review version of what happened. A couple years ago, my boss puts it on my desk. He says, hey, James, look at some of these problems and see if there's something you and your architecture team can do to add value with Intel hardware to solve these problems. Unfortunately, I went back to him in a week and I said, the problem here are users and passwords. And he's like, well, what do you mean? And most of the problems were along this line. Someone installed a server that was supposed to be a front-end consumer server to the web. In the back-end infrastructure, it was connected to an infrastructure server, and they had a connection in the data center they weren't supposed to have. And guess what the password was on both systems? Password! You got it. Or it was 1, 2, 3, 4, 5, 6, 7. So literally, you have major corporations getting breached and security impact because of these evil things called passwords, right? So one of the things that I'll tell you a little bit more about is when we set out to do this, we wanted to make sure you could do this and not leave this kind of a security hole in the mix as well. And I'm actually working with an industry group I'll tell you about later. We're trying to solve the password problem on a larger scale as well. So the problem statement and the thing that we are intent on doing is really making device provisioning plug and play, okay? So I'm from Intel, and Intel created USB. So that's all a model we go to quite frequently in terms of making something very easy and making it plug and play. So this legacy onboarding approach, you know, we're talking 20 minutes to an hour per device. It's slow, it's insecure, it's expensive, it's resource intensive. You can solve a lot of the problems today that you have here, but you really just push the problem somewhere else. And I'll give you an example of supply chain later as we talk about the Intel solution here. But really what I want to do is create this plug and play model similar to a USB solution. You know, with the IoT, for this market to really take off and conquer some of these challenges that I've talked to you about, we really have to be able to do this in a plug-and-play manner. It has to be fast. It has to quickly configure and know what it's supposed to be doing. It has to work across different hardware, work across different software, work across different operating environments, and it has to do it in a secure manner. So this is really what we set out to do as we were looking at this IoT market and figuring out how it would look a little bit stalled to us compared to what we would want it to be or would have expected it to be. Okay? So the Intel solution we came up with enable fast, secure, scalable device onboarding and activation. Okay? The product we have is called Secure Device Onboard. Now, one of the things about working at Intel is everything needs a TLA. Who knows what a TLA is? Three-letter acronym. It's a three-letter acronym for a three-letter acronym. So you will hear me refer to Secure Device Onboard as SDO, or I'll talk about like SDO-like solutions. So the team we pulled together, we said, hey, we want to be able to drop ship a device to someone. We want them to power up and connect to their network, and we want everything to be automatic from there on out. Automatically collect to your cloud, automatically provision what your system is supposed to look like, establish ownership for whoever the new owner is, and then turn yourself off, right? That's the problem statement. Some of the parameters we put in place for this problem statement, we want it to be zero-touch onboarding, which means we want it to, you don't have to have those 2 man-hours or 2 man-years to install things over a long course of time. We want it to be fast and secure, and the target we gave them was a minute. We want all of this to happen from the time the device is powered on. We want the infrastructure in place so this device is ready to go within a minute. Okay? Hardware flexibility. We want any hardware to work here. Now, this is something a lot of times people have a hard time understanding. We want everything from ARM MCU, which is the lowest power, lowest compute processor that ARM serves, all the way up to an Intel Xeon processor. Right? So big, lots more power envelope, a lot more performance envelope, right? Technically Intel and ARM are competitors. We are in the same business doing the same thing, but we work together quite frequently. We're a large customer of ARM. We use their IP in a lot of our products, and we actually partnered with them on this solution. So any hardware that you would likely find in an IoT device probably is on this scale from the ARM MCU up to the Intel Xeon processor. So we reached across the industry aisle, so to speak, and partnering with ARM to make this work. We want any cloud. That's a public cloud, a private cloud, an on-premise cloud, or a cloud infrastructure that you're taking advantage of from one of the major cloud service providers, right? We want it to have that kind of flexibility in the solution. We want it to be late binding. And we'll talk about the supply chain issues if you're not late binding. So we felt like the binding process needs to happen at the last possible minute, which is when the device actually lands where it wants to be. That's when you want to bind it and credential it and establish the ownership and load the capabilities on the device that you intend for the device to have. And then lastly, open with an industry standard and open source. We're actually working on that right now with an industry body as well as the Linux Foundation to open source some of the solutions that we have here, okay? Also, if you guys have questions along the way, don't hesitate to stop and ask me. If I need to keep us on track, I'll keep us moving, but this can be as interactive as you guys would like it. Any questions so far on kind of the market and what we're looking at and what we set out to do? Anyone? Okay. All right, we'll keep going then. So let's first talk about the supply chain. The interesting thing, SDO or SDO-like solution will deliver, efficient binding at the end of the supply chain. Now, you could do zero-touch onboarding today without using SDO. And that will allow you to overcome some of the security challenges and some of the supply chain challenges that we've talked about already earlier in this presentation. The problem is you just push the problems back to a supply chain problem. Okay, so if you want to install at the end and have it secure and not have to send those 2 man years of people out to do it at the end point, you can do that, but then you've just pushed a major problem into your supply chain. So if you look at the top here, if you look at a zero-touch model without something like SDO or an SDO-like solution in it, the first thing it requires is a build-to-order manufacturing infrastructure. That means you got to have custom SKUs for targeted customers before you start the manufacturing process. Then you have to take all these custom SKUs, push them through a custom supply chain at which some point they're going to get bound to their owner, and then finally they make it to an end user where an end user can actually use them. Now, if none of you have taken a supply chain class or a business class so far, this is a manufacturer's worst nightmare come true times 10. If you look at the SDO model below, the thing SDO allows you to do in the supply chain is you're not doing build-to-order manufacturing, you're doing single SKU manufacturing to plan. So you're manufacturing one device regardless of where the endpoint is coming. You put an identity in that device, you ship it through a supply chain. All along the supply chain, there's opportunities to align it so you can ensure the credibility of it. And then when it gets to the end customer here, it goes back through a binding process that links from manufacturing all the way to owner without creating the unnecessary complexities in here. Now, if you go to a Siemens or a Hitachi or a PC manufacturer, a server manufacturer, for that matter, if you go to an auto manufacturer, anyone with the word manufacturing in their title or that are making things, if you show them these models, you probably wouldn't make it through 2 words of the top model because this adds complexity, it adds cost, it adds overhead, it kills your financials when you have to talk about things like inventory through the process. So this is a manufacturer's nightmare, right? But today, if you want to do zero-touch onboarding in a secure manner, this is what you have to get your manufacturers to do. And with something like SDO, what we can provide in an SDO-like solution is we've put an infrastructure in place here that's much cheaper than the complexities that come along with this supply chain. And we do it in a way that allows the manufacturer to do one SKU and ship it through the process, and you still have the direct binding at the end that the customer really wants. Because what did we talk about in the beginning? The customer wants this any to anything, right? Any device, any cloud, any infrastructure, right? The only way to do that without an SCO-like solution is to create this manufacturing process. And I can tell you the answer if you go ask any manufacturer to do that. It's no, with maybe a few explicit terms thrown in for emphasis, right? Okay? So let's look at an SCO-like solution at the highest level. The next couple of slides here, I'll just kind of take you through some of the next level details on what this solution actually does and how we actually do it. Number one, so you have a manufacturer here, you have the recipient or the end customer, you have a target cloud, so if you have an infrastructure you want this to be a part of, you can identify it, and then there's an SDO service here as well. So next couple slides I'll walk you through some of the technical detail and the architectural detail of how we actually did this. So number one, you got a single SKU for multiple clouds and multiple customers. So standard manufacturing line, just like if you were making a router or some kind of device today, you would take it through your manufacturing line. You would pack it, either software or maybe even some warranty information in paper form. You put all that stuff in a box and you take it to your shipping department, right? The shipping department would then use the supply chain and get it to this end customer. So your end customer just bought your device, whatever that device happens to be. They open it up and they're saying, I'm going to put this device on this cloud, whether it's from Amazon, Azure, a backend cloud infrastructure that you have internally. You identify that and you say, this device, I'm going to put it on this cloud. So you communicate with that cloud infrastructure and say, this device is going to go here. Okay? The cloud then has an infrastructure that calls on the SDO service. So it says, I'm Cloud X, and I've got the infrastructure capability to support this device. Okay? So the SDO service, which is another infrastructure that exists for this solution, registers that cloud and is ready to hear from the device. So you turn the device on, and the device immediately goes to the service and the infrastructure that the SDO service is from. And it says, I'm this device, here are my credentials. It goes and registers with this service. Then the SDO service allows the cloud and the device to have this provisioning. So the SDO service sits in the middle. You can think of it almost like a DNS service or something like that. And it says, I've got this cloud that says it knows who you are. And the device comes on and says, hey, I'm that person. I'm that thing, that entity that the cloud is looking for. And they do the binding process from the cloud to the actual device. Okay? And then finally, once this binding happens, the cloud and the device actually have a secure channel of communication. And this is where, as the device owner, the cloud can then push whatever configuration you want, provision that device however you want it provisioned, give that device new keys and new secrets that you want it to hold that are relevant to your internal market. Okay? So at the highest level, this is the flow from the manufacturing piece to when the product turns on in the local environment. So we'll go into one more layer of detail here in terms of how this operation actually accomplishes its goal. You guys might be interested in some of this. We're going to talk a little bit about keys and cryptography and cool things like that you guys get to deal with probably on a day-to-day basis. So the high-level operation here, at the manufacturing step, when this device is being manufactured, there's a few things that must be present in order to make this system and this solution and this architecture work. So the microprocessor is going to have a unique root of trust key, okay? This root of trust key right now is based on either ECDSA or EPID. So EPID is Enhanced Privacy ID. It's a form of cryptography. And ECDSA is Elliptical Curve Digital Signature Algorithm, right? So those are the two key infrastructures for the cryptography we've chosen. And these root of trust keys actually go into a trusted execution environment. So with an ARM processor, you have a product called TrustZone. With the Intel processors, you have SGX, you have virtualization-based solutions. The Android operating system has a thing called Trusty. So each of these microprocessors supports the keying infrastructure, so you can do this root of trust key for the device in the hardware, in the microprocessor. And then they're all stored, those keys are all stored in a trusted execution environment. A trusted execution environment is just an isolation technology, right? It's one of the ways to isolate the key and protect it from other things on the system. So at the manufacturing, that's one of the prerequisites here. You've got to have one of the Intel or ARM processors that supports this keying infrastructure and has a trusted execution environment. The OEM will insert a GUID, or a global unique identifier. So there's going to be an identifier that really serves to let the device communicate with the SDO-enabled service and cloud. So each device that goes out will have this global unique identifier. Intel has a credential tool that we have available, so you can actually insert these secrets into the device or the microprocessor. Okay. This also, the Intel credential tool would also allow you, if you had a very complex supply chain where something is changing ownership over time, you can create key pairs. If it goes from an OEM to a distributor to a second distributor and then to someone at the end user, if you want to validate that supply chain, you can create some key pairs along the way that also help you make sure that the identity of the device is actually correct when it comes to its end user. Okay. The next thing you need is the SDO software, or the SDO-like software. ARM and Intel both have a version of this that you actually install. You can think of it as like a software program that exists on the device that kind of makes the device connect with the rest of the infrastructure. It's important, we designed this with that scalability I mentioned from an ARM MCU to Xeon processor in mind. The actual code's about 50 megabytes or less, so it's pretty small. And then it has very low demand on the microprocessor. So, if you're running this on a Xeon, you're probably not even going to notice it. And if you're running it on the lowest processor in terms of power and performance you can get from ARM or an ARM licensee or another vendor, it's not going to take up a lot of the horsepower or the memory space. And then lastly, the OEM creates a digital ownership voucher that's sent with the device. And again, just like you send things today with a device you make, whether it's a warranty card that's in the box or any firmware or software you install, the OEM would actually do that as well. And that ownership voucher is going to be the way that end device, when it gets to its end user or its home, that ownership voucher is going to be what starts the process to get it onboarded with the cloud infrastructure and the SDO infrastructure. Okay? So there's a few things like that you have to do in the manufacturing process that's very consistent with what you do today. We're not asking for a lot of changes. Before installation, so once the device actually arrives on site, before you actually start to install it, the ownership voucher and the global unique identifier are put in the cloud you're going to install the device on. So your cloud has to be able to identify it when it turns on, and that's how part of the importance of the binding process. So before you turn your device on, this ownership voucher and the global unique ID is put up into the cloud, and the global unique ID and the IP address for this target cloud is sent to the SDO server. So, the ownership voucher and the stuff comes out of the box or comes out of the actual device, and then you register it with the cloud and the service. That way these connections can actually happen automatically when the device comes on. Okay? And then at installation, what happens, the device power is on and does the phone home and identifies itself to the SDO service, right? So the device is in your factory, on your oil rig, in your smart home, your smart building, wherever the device is, it gets on the network and identifies itself to the SDO server. The SCO server makes the connection with the cloud. Okay, the cloud and the device mutually identify each other. This is a cryptographic handshake, right? This is how we ensure the integrity of the system here, right? The cryptographic handshake takes place. They identify each other through the root of trust, the GUID, and the ownership voucher, and then they set up this secure tunnel between the device and the cloud. So again, once this tunnel is up and running, it's done in a way so you can ensure the security of it. And then finally, you can also use that to provision that device. You can point it to certain URLs. You can put certain configurations in the device, right? You can give the device new keys, right? Because after this point in the process, SDO shuts down, okay? The SCO service is done. It's performed its job. The new owner's been identified. The product's been provisioned. The SCO work is done, right? So at this point, this device now becomes owned with the keys and the infrastructure that the owner wants to have, right? SDO is gone. There's only one part of the SDO solution or the SDO-like solution that stays with the device. And that one thing is the root of trust. The root of trust that's in the trusted execution environment in the microprocessor is the only thing that's mandatory to stay in the device at the end of the day. Can anybody think of a reason why you would want something left in that device that could identify itself and take it back through this process again? What's that? Secondhand market. What if it changes ownership? You want to be able to do this again and do it securely? You can restart this whole thing with that unique identifier in the trusted execution environment. There's one more reason we had in mind other than changing ownership. What's that? Stolen. I consider that same usage model as the other one is if the device has to be reprovisioned. What if the device gets shut down? What if you have a physical attack in your environment and somebody pulled a cord out of it and you weren't sure you could trust the integrity of it anymore, right? So we wanted the SCO solution to remove itself as much as it could, and the GUID, the other things, those are all replaced with new keys and new ownership and new security models that the end user wants to have. But we want to be able to do this again, and that unique identifier in the silicon that's protected that way is the way you can restart this whole process again. Okay? Probably won't do this one. This is just kind of a little more about the actual interchange, and I think we covered all of that in the general overview. So, what are the major software components of this? You've got to have the processor that has the trusted execution environment and the ability to do the ECDSA and the EPID keys. There's no reason you couldn't do other forms of cryptography, RSA and other forms of cryptography there. We just chose these because they're widely available and fairly easy to do. We could expand that capability over time. So you got to have that processor. You got to have the agent, either the agent from the ARM class of processors, the agent for the Intel class of processors. That's the local software that's shipped with the device. The manufacturing credential tool, this is how you put the global unique identifiers in. So that's part of the software solution here. The rendezvous server or the SCO server. Again, this is when Intel has this service up and running, but we also would we would basically show someone else how to do this. So if you were a large industrial manufacturing giant and you wanted to use an SDO or an SCO-like solution, but you didn't want to use the Intel infrastructure, you could go build your own SDO rendezvous service. It's pretty similar to most DNS services today, so most IT departments could probably build these up pretty quickly. And if you want to put that trust infrastructure in yourself, you're more than welcome to do it. The target cloud, you got to have your target cloud ready. We'll actually talk about this. This has actually been demonstrated. We've used this with a smart building in Japan with the ARM Pelion. ARM has an infrastructure called Pelion where we've actually done this. So this isn't just an idea or a proof of concept. This is actually real working software that's in the market today. And then reseller tool, if you want that secondary market or other opportunities here, there's a tool where you can restart the process as well. Okay. So there's these are just fundamental pieces. And as you can look and see, we're looking to make all of this open source over time, right? So we want to be sure that, that we get the benefit of the industry working and the benefit and the scale of the industry working to solve this problem, because right now we're nowhere close to the 1.6 trillion devices. And as a guy that sells CPUs into each one of those, I would really like us to get close to the ability to sell 1.6 trillion of these. Just a potential application. So, okay, well, yeah, James, this is great. I got your crypto. I see your service. What are you going to do with this, right? Here's an example of an IoT system that exists in many places today, and how you would use STO to do it. You could automatically onboard cameras, street cameras for traffic violations. I hate those things. I don't want to necessarily make those things better, but I guess you could with this solution. You've got these cameras. You could automatically onboard them to a recorder. You could automatically onboard a recorder to a cloud. Let's say you were responsible for the traffic recording lights of a large city in California. You could onboard those to a recorder. You could onboard that recorder to pick your favorite cloud service provider, so you can store all that data that's coming through in imaging. And then lastly, you can automatically onboard cameras directly to the cloud. So if there's other sets of cameras, a street corner camera and a camera on top of a light, they're two different systems. You want to put the data together, you could onboard them both in very unique ways. But at the end of the day, you could put a system together where if you're responsible for traffic and sidewalk cameras in a large city in California, you could use SCO or an SCO-like solution to onboard those and make them work, so you're not paying tens of thousands of people tens of thousands of dollars to go do this manually over time. The other question we often get when we talk to customers about this is, what about the firewall? Many IT infrastructures today don't allow things to just come up on their network and call somebody. That's called a hack. In a lot of infrastructures, and your IT department that's monitoring your network traffic is going to see some random thing come up and try to make a call to some random server they don't know, and they're going to squash it, right? So one of the things we've accounted for is, we've found a way to make this work. So your firewall, you can put policies into your firewalls that say, these IP addresses are only going to have SDO-enabled things. So if you see this kind of behavior, it's not hacking traffic in your infrastructure. It's actually something valuable that we're trying to do. And then you could have part of that infrastructure, so non-devices. So there's a default policy at the smart router level, so you don't get yourself in a situation where you can't tell your SDO, your SDO-like solutions from your non-SDO or SDO-like solutions, because again, if you're looking at a network and you see this behavior go on, you should automatically be skeptical, right? So we had to account for that in the system as well. So we've got some policy and some way to make the device actually be smart and know that it's working in an SDO-enabled market, right? I mentioned the partnerships. So, there are many times in the industry, I have an MBA as well, right? So we're talk about maximizing profits and making money for our companies, right? There are times when the best thing you can do is go make a lot of money as fast as you can in something that you have is unique. I've also learned over the course of my career, there are also times when a float all boats strategy is the best thing you can possibly do, right? So with SDO, to make this IoT market take off, we feel like this is an area where we should be partnering with the industry to make this work. I think I can benefit from it. I think ARM can benefit from it. I think the industrial providers and the IoT providers can benefit from it. So we've actually reached out and done a couple partnerships here. The first one is with ARM. So you can see the Intel processors, the ARM processors are both enabled to do this. There's some minor differences between how we do it. Ours is EPID-based, theirs is ECDSA. Again, we could do the keying differently if we wanted to, or make those investments over time. But we're actually working at the silicon level, and we work together with OEMs and ODMs some of the cloud and IoT platform providers. We actually walk into meetings together and people are like, why are the ARM and the Intel guys here together? They're usually trying to sell me different things. And we walk in together and say, SCO is going to work and we're going to work together on our side to make it work, right? So we've actually had some of these meetings together. And then we're also working together on the standards and the open source side. So you can see the industry is really, the IoT industry has really embraced this. This is kind of a working together for the overall good. The next thing we've done in order to make this market work and enable it faster and better, there's an industry alliance called the Phyto Alliance. And Phyto stands for Fast Identity Online. And what we're trying to do in Fast Identity Online is we have everyone from Intel and ARM. We have Synaptics, who's like a biometrics vendor. We have Microsoft. We have Google. We have Amazon. We have the cloud versions of those companies as well. We've got the banks that are relying parties or end users that you're using on the web all the time. And we're really trying to put together an infrastructure so we can get rid of passwords. Okay? We've got identity and authentication environment that we've standardized across the industry that's implemented in Intel and ARM hardware. It's implemented in the browsers and the operating systems from Microsoft as well as Google. And we're talking to other folks that can help us there as well. And then the banks and the relying parties are figuring out how they're going to go actually implement this. But we've actually also, ARM and myself, from Intel, we actually went to the Phyto Alliance and said we would like to get into the IoT business as well because we want to solve the onboarding problem. Because if you don't solve the onboarding problem correctly, guess what? You've created another password nightmare where you're going to have 1 million devices with the password of, let me hear it, password or 1, 2, 3, 4, 5, 6, 7. So we don't want that infrastructure to take place. So we're working together in the Phyto Alliance. We just kicked off an IoT working group. Some folks from Intel, Google, Microsoft, you name it, Amazon, we're all there working on these specs. So we're going to donate the architecture we've done with SDO, and then we're going to take the code that we've written that makes SDO works and open source it through the Linux Foundation. So Phyto, you will see Phyto active in this community where hopefully within the next 12 months we're going to come out with an architecture that says if you want to do fast passwordless onboarding for IoT devices in a secure manner, here's the way to go do it, and here's the industry partners that have worked together to make it work. Okay? It's been a great effort. Phyto in general does a lot of good things. It's got a lot of unique people involved in it and a lot of unique parts of the industry. So I'm really optimistic that we're going to be able to make something happen here so the industry can solve this problem in a standardized way. So we've had this product in the market for about a year and a half, so we do have people that have used it. Palo Alto and Fortinet, I used it to show edge security at the RSA conference. We've done stuff with the oil and gas, British Telecom, smart building infrastructures in Asia. So we've actually had an opportunity to go test this and make sure it works. With real customers doing smart buildings, doing infrastructure that are like smart infrastructure in industrial settings. So we've been able to create some good opportunities here to solve this problem, and we're hoping to take it in a very broad fashion through the industry alignment and the industry alignment we're getting through Phyto and the IoT working group. I've got a few places here you can see, again, like with ARM, the ARM Pelion Cloud. That's a cloud infrastructure they have for their customers. It's enabled to do this. We actually have working demos that you can see online. There's SDKs that are available. There's overview collateral on the Intel website that you can use to actually get some inside an infrastructure. You can get the SDK, figure out how to make this work with various operating systems. But we feel like this is it's an important problem. Like I mentioned to you before, the IoT market is so exciting to me because the upside just financially, the upside as a business is tremendous. And the other thing that I think I shared with you earlier, I love a hard problem to solve, right? And there's business problems, there's supply chain problems, there's technical problems, there's policy problems. When you start talking about the IoT as you get into medical devices, there's legal problems, right? So there's all kinds of really cool things that you can solve in this market. And if we want it to be the market that it's being promised to be in all these forecasts, we've got to solve the security security and the installation problem. So this is one way that at Intel we took a set of hard problems, and yeah, it's just the security and the onboarding piece, but that's the first barrier. You know, we're going to work together, work with the industry, solve that problem, and maybe there'll be another one we need to solve after that. But that's the exciting thing about working with the industry and at a company like Intel, is you can tackle some of these problems and you can work with your partners in the industry, and you can really literally go move and shape industries. And I think that's the kind of opportunity we have, and we're going down the first step of with the IoT market with these STO-like solutions that are in the market today. So that's all I had. Do you guys have any questions for me? Questions? Comments? Feedback?
I have a question.
Yes.
Regarding Intel's SDO service, would the SDO for an IoT device provide trusted handshakes only with recognized cloud service providers?
You could do it without identifying the cloud, but you don't have that level of trust to do the provisioning. So you could onboard the system that didn't have a cloud infrastructure with SDO in a secure way, but the provisioning and all the other things, you're going to have to solve those problems locally with a person. So, you know, there are pieces of this you could take independently to solve one of the problems, but like you couldn't do the late binding automated provisioning if you don't have the cloud infrastructure enabled, but you could still bind the device to the owner through the SCO service. You're just not going to be able to have that secure handshake with the cloud to do all the provisioning and ownership. So you might still have to send someone out to touch the device to do some more of the onboarding.
So it'll just be a little more time-consuming.
Yes, yeah. You don't solve the time and scale problem as well as you could. Yeah, yeah. Good question though. Any others? Don't ask me any crypto questions. She can answer those. Okay?
Okay, any more? Let's thank our
All right.
speaker.
Hey, thanks for the time. I appreciate it. Yeah.